This video is about the shadows of rectangles, but I encourage you to see the previous videos so you can better understand what I'm saying here. I'll talk about two basic types of rectangles. There are the upright rectangles. If they have a hole, you think of an arch or an open door or a window. And if they're floating above the ground, you think of a sign. A horizontal floating rectangle would be parallel to the ground if it's like the seat of a bench or a tabletop. But it could also not parallel to the ground, particularly box flaps. Here is an upright rectangle and its shadow in one-point perspective. So we take the two sides of the rectangle and find the light triangles to find these intersections here, connect them together, and you've got the shadow. Now, if you want to put a hole in it so that it looks like an arch, here again we draw the light triangles that go through the base of the poles. Cut out the part that you want empty in the middle, and then start making little light triangles so then you can find this opening, the shadow that corresponds to this opening. And you end up with this shadow over here. Unlike the previous slide, which is in one-point perspective, this one has 2 points, the shadow vanishing point and the vanishing point for the rectangle. So draw the rectangle in perspective and then find the light triangles for both vertical sides so you can find these intersections. And here is the shadow for this rectangle. To find window light, cut out the window and start finding light triangles for the top of the window here and light triangles here for the bottom of the window, and you connect them together and you have a little light spot in the shadow corresponding to the window. And to check your work, these lines should all go toward the same vanishing point, while these lines go to the vanishing point for shadows. This rectangle is on the ground, so we can send shadow lines through its base, and when it reaches the wall, it goes vertically up, following the vertical casting pole, not because the wall is vertical. In the second case, the rectangle is floating, so pass light rays through all four corners, and an easy way to finish this is just to have the edges of the shadow parallel to the edges of the rectangle. But most of the time, you should use seats through which the shadow lines would go, and then you can go vertically up and intersect the light. So you can use this method to find shadows, and it's also useful to find window light. And let's see if we move the light back, what happens. You can see that the shadow gets smaller. And if we move the rectangle closer to the casting surface, the rectangle shadow also gets smaller. These are upright floating rectangles, meaning they don't touch this casting surface. This one is parallel to the wall and this one is not. So in this first case, the wall and let's call it a sign, goes to the same vanishing point. Set up the seat line, and then the shadow lines happen to be horizontal here. They go up until they intersect the light. So the shadow ends up being parallel to the wall. Now, an upright floating rectangle, not parallel to the wall, I recommend numbering the corners. So number 1 here goes to intersection 1. Then the rest of this vertical pole the shadow travels horizontally and then vertically up to intersection 2. This horizontal pole from 2 to 3 creates a diagonal shadow from 2 to 3 here. And then the last vertical pole goes vertically down to intersection 4. And when there are no other intersections on that plane, just continue in the same direction until we reach the edge of the wall. Then it goes to intersection 5, which is part of this horizontal pole. To find the shadow of an upright rectangle using front lighting, Establish the two poles on either side of the rectangle and draw shadow lines from their base to the shadow vanishing point on eye level. Then determine where you want the pseudosun and draw light rays through the top of the poles. And where the light rays and the shadow lines intersect are 2 points on the shadow. So far we have the shadow of these vertical poles. If we connect these two green lines, then this whole part is the shadow, as I show here. Unlike the previous rectangle, which only had one vanishing point, this one has two, one for the rectangle and one for the shadow. And you can see the top and bottom of the rectangle, including their shadows, go to the vanishing point over here, while the parts of the shadow that go through the base of the pole go to the vanishing point over here. To finish up the shadow, find where you want the pseudosun, draw light rays through the tops of the poles, and find where they intersect the shadow lines here and here. In this second case, the rectangle is floating, so you have to create seats, but otherwise it's the same construction. Horizontal rectangles that are parallel to the ground are common, like the seat of a chair or a tabletop. And all you need to do is use the legs as poles, so you have shadow lines going through the bottom of the legs and light rays going through the top to find intersections on the shadow. And this is the same thing except with side lighting. For this chair, I would start with the seat, which is a horizontal rectangle, and find its shadow on the ground like this. And it attaches to the shadows of the legs like that. And remember that this is the shadow direction because it's going toward the shadow vanishing point. It's going in the same direction as the light, which is going up in this manner. And it goes under vertical poles. Now, what about the back of the seat? Well, we can treat this back like a horizontal pole and with light triangles find its shadow. What about putting a seat down so that it's attached to the ground? We could do that, but it wouldn't change the shadow direction, which would be here. For this shadow, find the direction of the light, which would be up in this direction. So the shadow direction must also angle up toward the right. Since these light rays are parallel, we can draw light triangles and just have them all have the same proportions. So that would be one, for example, and then we could go from this foot down to the foot and up so that all these triangles have the same height to width ratio. Box flaps are a good example of floating rectangles that aren't parallel to the ground. So let's take this front flap and give it seats, although it's unclear exactly how far down the seats should go. So let's then go to the shadow direction, which would be underneath vertical edges of the box. So that one shadow direction would be here, and using this corner, we can get another shadow direction that goes like this. And they're parallel because you see the light is parallel. Once you have that direction, then we know in order to get this point, the shadow direction must go like this. So this would be the end of the seat, and we would then connect it to this other seat here, and then we can find the shadow direction and the light to find this point here. The problem with this shadow is to find the shadow direction. And there's really only one place to find it, and that's at this corner right here. And you can see that it goes in this direction. So when you set up your seats here, you must make sure that all the bottoms or the shade lines on the seats go in the same direction as this first line. And then you can find all the points on the shadow. When you have a complex form like this, break it down into its components. So you can start with the vertical poles, which are the legs, and find their shadows. Then you can go to the horizontal square and find its shadow. And these two are usually look about the same if the two surfaces are parallel, which they are, and if the light rays are also parallel. Although the shadow is usually a little wider than the seat because it's further from eye level. And then finally do the back of the chair. You can do it upright, find the shadow of an upright back, and then you can just twist it back a little bit to account for this incline, and do the same with the shadow. To find this window light, let's start with the two intersections for the base of the window, and that gives us intersection 1 and 2. Then get intersection 3 over here, and we know that this line is cast by this vertical side of the window. This must go in this direction because it's cast by this horizontal pole, so it has to be converging or parallel. And it lands on point 6, but we don't know how to get to point 5. So go around the other way whenever you're stuck. And so for number 1, just continue the shadow line until it hits the wall. Then it goes vertically up because it's being cast by this vertical side of the window. And then we can find intersection 5 and connect it then to 6. This tabletop is a horizontal floating rectangle, and I'll show you how to light it with two sources. Here I found the shadow for the first light source using the legs as vertical poles. Then I overlapped the second shadow onto the first, and they each lighten the other's shadow. In other words, this orange light here lightens the shadow that is created by this light, and vice versa. So the only part that's the darkest is where neither light reaches, the part that neither light reaches, which is right here. This bench is lit by two light sources, and we can see with the stronger light source, we have a full shadow of the bench. But with the weaker light source, we only get some shadows of the legs. And so the darkest shadow would be the shadow of the leg that's within this blue shadow. So that's it for shadows of rectangles. And the next video is going to be about shadows of boxes.